Welcome to Skillzam, a cure platform, cross-skill, upskill, reskill, and expert skill. We are your best learning partner for life. Skillzam, keep learning. Welcome to the Skillzam section on logic gates. In this section, you will learn about AND gate, OR gate, NOT gate, and so on. Also understand on how logic gates help human thinking. NOT gate. So before we understand the different kinds of gates, let's first understand what are these logic gates. We send information through computers using wires that represent ones and zeros. Computers need a way to manipulate those ones and zeros so that they can eventually do more complicated operations, like for example calculating the 50th digit of a value pi 22 by 7. So computers use logic gates to transform ones and zeros from input wires. Logic gates are basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on the certain logic. Based on this, logic gates are named as AND gate, OR gate, NOT gate, etc. So now let's understand the simplest example of NOT gate, also known as an inverter. It accepts a single input and outputs the opposite value. A diagram showing a single wire going through a NOT gate. The wire is in the off state, signifying 0. The output wire from the gate is in the on state, signifying 1. If the input is 0, the output is 1, just the opposite. A diagram showing a single wire growing into the NOT gate. The wire is in the on state, signifying 1. The output wire from the gate is in the off state, signifying 0. So that is, like if the input is 1, the output is 0. Inverting a value may seem like a trivial operation, but in computers we can build highly sophisticated logic by combining many small operations. Now on the screen, if you can see on your left, there is a table for NOT gate. This table is nothing but a truth table. So what is a truth table? A truth table shows how the truth or falsity of a compound statement depends on the truth or falsity of a simple statements from which it's constructed. So we will start by looking the truth table for many of those logical connectivities as we learn further. Now in this truth table there are something called as a tautology and contradiction. So now a tautology is a formulae which is always true. That is, it is true for every assignment of truth value to its simple components. You can think of a tautology as a rule of logic. The opposite of tautology is a contradiction, a formula which is always false. In other words, a contradiction is false for every assignment of a truth value to its simple components. AND gates. All other gates operate on multiple inputs. The AND gate accepts two wires, and if both of those wires are on, obviously it is represented by 1, it outputs 1. The example here shows there are two wires with are in off state, that is carry 0 as its value, going through a AND gate, and output of the wire is always off, that is 0. Just the opposite would happen when the wires are on state, which carries a value 1. Both the wires enter the AND gate and outputs the value 1, which is on. So AND gate is a Boolean operation, an operation that are either true or false and outputs true or false based on the logical manipulation of those inputs. In logic gates, we consider 1 to be true and 0 to be false. On your left, you can see a truth table for AND gate. The output is 1 if and only if the inputs of A and B are 1. In rest of all the cases, the value of the output is 0. OR gate. The OR logic gate accepts two inputs, and as long as either of those input is 1, its output is 1. Based on that description, what value do you think this OR gate outputs? Let's look at the truth table of OR gate. As you can see, the output is 1 for every row except 1. The only time that an OR gate output is 0 is if both the inputs are 0. Let us now consider other logic gates. Their truth tables are just given on the screen. The computers also use other logic gates like NAND gate, NOR gate, XOR gate. Each logic gate operates on inputs in a significantly different way. They output 1 or 0 in different situations. In fact, the NAND gate and NOR gates are known as universal logic gates, which means that we can build any of the other gates with only NAND gates or only NOR gates. Computer hardware manufacturers prefer to use NAND gate due to its universality and ease of fabrication. So, your computer likely has millions of NAND gates inside its circuitry. Logic gate aid logical human thinking. It might help you to think about what these gates can do in human speech. Consider this OR gate. The first input represents I know to bat, the second input represents I know to ball, and the output represents I can play cricket. An example shows one wire next to the bat and another wire next to the ball. Both wires go through a gate that says OR, and the output wire is next to the folks playing cricket sport. If I know to bat or I know to ball, then I can play cricket. We can say that more verbosely, like if it is true that I know to bat or it is true that I know to ball, then it's true that I can play cricket. This means that if I know to bat, regardless of whether I know to ball, I can play cricket. And the same thing goes the other way. If I know to ball, regardless of whether I know to bat, I should play cricket. The only time I should not play cricket, according to this gate, is when I don't know to bat and I don't know to ball. That was a vast simplification of the complicated logic that humans compute when we decide whether to play cricket. But it shows you that the logic is something that relates very much to the real world outside the computer. Logic circuits. Computer often chain logic gates together by taking the output from one gate and using it as an input to another gate. We call that as a logic circuit. Circuits enable computers to do more complex operations than they could accomplish with just a single gate. The smallest circuit is a chain of two logic gates. The inputs A and B first go through an AND gate. Then the output of that gate goes through a OR gate combined with another input C. Now, interesting things can happen based on which inputs are 1 or 0. This section demonstrates that logic gate helps logical human thinking. Also, more complicated computer logics can be broken down into simpler components. Thank you for learning with Skillzam and never stop learning.